In section 12.4, we're going to do some multiplying and dividing rational expressions. Since these are basically fractions, multiplying and dividing is easier than addition and subtraction, which we'll get to in 12.5. But in order to multiply, we need to remember that if you multiply two fractions together, you're really just multiplying everything on the top and everything on the bottom and dividing them. So you can do this a couple different ways. You could just think of it as one giant multiplication problem, like this first one, 1a, just everything on the top divided by everything on the bottom. And then you can start simplifying things. You have numbers on both top and bottom, and then some of our expressions there. So what I always like to do is to break down each part of my expression before I start doing any multiplication, and then it's really easy to cross stuff off. So the first thing, c minus 4. I can't simplify it all, so I'm just going to leave it, c minus 4 times the 45. And then in the denominator, I have 5, which can't simplify. But then I have this term here, negative 4c plus 16. And I can factor that. Since this first term is negative, I'm going to take out a negative 4. So this will be times negative 4. And I'm left with c minus 4. So once I did that, I can see that some stuff is starting to cross off. I have c minus 4 on both the top and the bottom that can go away. And then I'm left with the number 45 over negative 20. And that's something that, again, we can simplify. 5 goes into both of those numbers. It goes into 45 9 times, and it goes into negative 20 negative 4 times. So 9/4 is what that big, giant, messy expression simplified to. So let's try the next one. Lots of things on both the top and the bottom that we can get to cross off. So this goes back to the monomial stuff that we did back in the day. You can simplify each individual fraction, or you could multiply things together first and then simplify. Tons of different ways to do this. What I'm going to do is simplify everything on the top and then simplify everything on the bottom and then see what can cross off on the top and the bottom. So on the top, if I multiply my numbers together, I get 10. I only have 4 x's, and then I have y to the 5th times y squared. And remember, you got to add your exponents. So I end up with y to the 7th, and then just 1z. And then in the denominator, if I simplify, I get 12 x squared y cubed z. And now we can start crossing stuff off or getting things to simplify. So 10 divided by 12 is really 5 divided by 6. I have x to the 4th divided by x squared. Remember, that means I do 4 minus 2, so I get x squared in the top. And then y's, I have y to the 7th divided by y cubed. So if I subtract those, I end up with y to the 4th. And then my z's, I have 1z on top, 1z on bottom, so those cross off, and I'm done. So the next one's a little trickier. It says to multiply m minus 5 divided by m squared minus 4m minus 12 times 3m plus 6. So remember, we can rewrite this as m minus 5 divided by m squared minus 4m minus 12 times 3m plus 6 all over 1. And then it turns back into the first problem that we did, where everything on the top is multiplied together and everything on the bottom is multiplied together. So I'm going to simplify some things as I go. M minus 5 can't be factored, so I'm just going to leave it. But to remind myself that that's one term, I'm going to put it in parentheses. And then also on the top, I have this 3m plus 6. Both of those things have a 3 in common, so I can factor that out, and I'm left with m plus 2. And then on the bottom, I have this trinomial that I need to see if I can break down. So I want to ask myself, are there two numbers that add to make 4 and multiply to make negative 12? And there is 6 and 2 will work here. And the 6 needs to be negative. So this can be simplified into m plus 2 times m minus 6. And then we see what we can cross off. So both of these have an m plus 2. That can go away. And then there's nothing else. M minus 5 and m minus 6 are two totally different numbers. So we can't cross those off. And we can rewrite this as 3 times m minus 5 on the top divided by m minus 6. And remember, just because both of those things have an m doesn't mean that we can cross those off. So these ones look a little more complicated. Why don't you guys pause this and give these ones a try. Alright, so for the first one, 3a, you should have factored a bunch of stuff out, and you should be left with n plus 4 on the top divided by n times n plus 2 on the bottom. And now the second one stayed pretty messy even when you got done simplifying it. Not everything's simplified. Be very careful. This p squared plus 16 is not something you can factor. A lot of people were tempted to factor it on the test. So make sure that's not a difference of squares, it's a sum of squares, and you can't factor that to p plus 4 times p minus 4. So it still stays this messy answer down here, but we simplified what we could, so we're done. So moving on to division. Dividing fractions, we need to remember to keep it, change it, flip it. Keep it, change it, flip it. So you keep the first fraction the same, you change the sign to multiplication, and then you flip the second fraction over. And then it just turns into a multiplication problem. So let's do one together. I'm going to skip 4b. You guys can try that at home. But let's do this first one, 4a. So I keep the first fraction the same, change the sign to multiplication, and then flip the second fraction over. And then I see what can simplify. Nothing's going to cross off, but I can combine everything to get 3 times x minus 5, all divided by x to the 5th power. And we're done. 4b, again, you can do at home, and we can go over the answer tomorrow in class. But 4c is pretty interesting. Remember that this second term has a 1 underneath it. So when we flip it over, it's going to have a 1 on top. So you should get x squared minus x divided by x plus 2 times 1 over x squared plus 2x minus 3. So remember, keep the first one the same, change the sign to multiplication, and then flip the second one over. And then if we start simplifying this, first thing I want to do is see what I can factor out of everything and anything. So the very first one, x squared minus x, that has an x I can take out. And I'm left with x minus 1. The denominator can't be factored, so I'm just going to leave it as x plus 2. And then we're multiplying times 1, so that doesn't really do much. But then this bottom can be simplified. And this can be factored into two numbers that add to make 2 and multiply to make negative 3 are going to be x plus 3 times x minus 1. And then we can see that the x minus 1's cross off, and that's it that crosses off. So on the top, I'm left with an x, and on the bottom, I'm left with x plus 2 times x plus 3. And we're done. So division is basically multiplication. You just have to remember one extra step in the beginning. So let's do a story problem with this stuff. This story problem has to do with probability. So Marty is playing a carnival game. He needs to pick 2 items out of a bag without looking. The bag has red and blue items. There are 3 more red items than blue items. Write and simplify an expression that represents the probability that Marty will pick 2 blue items without replacing the first item. Let x represent the number of blue items. This is super important. So we know nothing about probability, but we can still figure this out. How could we represent the red items? Well, this said that there are 3 more red items than blue. So if x is the number of blue ones, the number of red ones would be x plus 3. How could we represent the total number of items in the bag? Well, we have blue plus red in the bag. So let's take a look at our equations. Blue was x, plus our reds were x plus 3. So the total number of items in the bag is 2x plus 3. So now we're going to use that information to figure out the rest of our problem. It says the probability of picking a blue item and then another blue item is the product of the probability of the individual events. So what is the probability of picking the first one to be blue? Well, if I told you there was 4 items in the bag and only 1 was blue, it would be 1 out of 4. So we can use what we learned up here, or what we wrote down up here. X is the number of blue items, and 2x plus 3 is the total. So the probability of picking a blue one is x out of 2x plus 3. So what's the probability of picking that the second item is blue after the first one was blue? Well, we started with x amount of blue ones. We picked one out, so now we have x minus 1 blue ones left. And the total is now 2x plus 2, because we took one out of that 3. So then what's the probability of picking both items blue? So if we go back up to this, it says that the probability of picking a blue item and then another blue item is the product, or multiplication, of the probabilities of the individual events. So we have the individual events. X over 2x plus 3 is the first one, times, because we have the product of x minus 1, divided by 2x plus 2. So we can multiply these things together. See what you can factor out, see what you can simplify. X can't do anything, and x minus 1 can't do anything. And on the bottom, 2x plus 3 we can't do anything with. But then 2x plus 2, I can take out a 2. And I'm left with x plus 1. Nothing crosses off though, so I'm going to rewrite this so it looks a little prettier. Let's put the 2 out front here, and then we'll have 2x plus 3 times x plus 1. So this is the probability that I pick 2 items that are blue. Pretty messy, but it's going to help us with the next part. Part B says, what is the probability that Marty picks 2 blue items if there are 10 blue items in the bag before his first pick? Use the probability of picking 2 blue items that we just found. Since x represents the number of blue items, substitute 10 for x. Simple enough. Go back up to this equation, and everywhere you see x, place it with 10. So we have 10 times 10 minus 1 divided by 2 times 2 times 10 plus 3 times 10 plus 1. So on the top here I get 10 times 9. On the bottom I have 2 times 23 times 11. And on the top we get 90. Can't do multiplication apparently. And at the bottom, 2 times 23 will give you 46. If you multiply that by 11, you get 506. Probability is most of the time represented in a percent or a decimal. Like 90 over 506 doesn't really make much sense. But if we divided those two things, we end up with 0.178. or about 18%. That's the probability of him picking 2 blue items. Not very high.